Welcome to the model of the series of lectures that we are giving to make things easy in physics. This module will be confining with kinematics at a very basic level. Most of the terms that come in kinematics will be velocity, acceleration, displacement, and of course how they change with respect to time. T here is the time. When we try to speak of velocity, this velocity can be broadly classified into two. One is called the average velocity and another is called the instantaneous velocity. The average velocity is supposed to be the change in the position divided by the time it has taken, or we can say that this is called Rf minus Ri divided by Tf minus Ti. So this is a vector, this is also a vector, and hence we put an arrow on the top of it. So that's called average velocity, which means how much time has it taken for itself to undergo a change in position. That if you can divide by the time it has taken, that gives you the average velocity. I can show you here if this is supposed to be the y-axis and this is the x-axis. Imagine that this is supposed to be some point and this is what is called Ri at a time which is called Ti. Let this point move to another location and so I can call this as Rf and the time here is Tf, and we understand Tf is greater than Ti because time has rolled forward. So now the question is, what was the displacement that is supposed to be called as the change in the position, and that we call it as Rf minus Ri. So we are able to see that this itself is called the displacement. The particle might have traveled along this curve, but then we say the displacement is the shortest path from the initial position to the final position, and that's what we call it as the average velocity. The units of this is meter per second. Now if I can trim down this time interval, then I think we are going to get the position of this particle. If I can see at a previous time, then the particle keeps on being sighted a little before this as we go in terms of time. Then we find that as delta t tends to 0, this should not be made 0, it should be shrunk sufficiently. Then we can say under that limit delta t tending to 0, delta r upon delta t can be written as dr upon dt, and this I call it as the velocity. What sort of a velocity is this called? Instantaneous velocity, whose units are meter per second. Similarly, we go by the same way as far as acceleration is concerned. We say average acceleration is again change in the velocity by the time taken, and this is the final velocity minus initial velocity by the duration of time which has taken for the velocity to undergo a change. And if case we can reduce the time interval, then we can say the instantaneous acceleration is supposed to be limit delta t tending to 0 and here delta v upon delta t, and that will be now written as dv upon dt, and this is what I call it as instantaneous acceleration, whose units are meter per second square. That's supposed to be the acceleration what we are going to have. So we have understood that acceleration is the time rate at which the velocity changes. So I can call here that this is dv by dt. So you may be interested to know what does this mean. I would only say that this is the rate. When I say rate, then rate can be explained in terms of how rapid was the rate or how slow was the rate. That's a very important thing. If it is very rapid, I think then the value of this acceleration is very high. And if it is not very rapid and if it is very less, the rate is very less, then the value of the acceleration also is very less. On the contrary, suppose this v is a constant. Imagine v is a constant, which means it doesn't change. When it doesn't change with time, then there is no question of any variation at all. V is not varying at all with time, which means acceleration is 0. So acceleration will be 0 if velocity remains constant. We calculate acceleration only when velocity changes with respect to time. That's the basic idea. Now, if velocity changes with respect to time, now question comes, at what rate is the velocity changing with respect to time? What is that? Is it very rapid or is it less? What about the rate? That rate, is it more or less? Based on that, I think the value of the acceleration will change. So this is supposed to be one module where we have introduced what an acceleration is. Similarly, when we come to velocity, we again say dr upon dt, and that is called what rate at which the position vector is changing with respect to time. And when it comes to displacement, remember, it's always the final position vector minus the initial position vector, which is called displacement, or it's just a straight line from initial position to final position. So displacement is always Rf bar minus Ri bar, where Rf bar is the final position vector and Ri bar is the initial position vector. Thank you.